Hello children, welcome to Math Simplified. This video is for 10th standard students. Please subscribe and share with your friends also. We are going to study types of functions today. There are 4 different types of functions. The first one is one-to-one function. A function f from a to b is called a one-to-one function if distinct elements of a has distinct images in b. It is also called an injection. So here is an example. A is equal to 1, 2, 3, b is equal to abc. A is the image of element 1, b is the image of element 2, c is the image of element 3. So here distinct elements of A has distinct images. So it is called a one-to-one function. Many one. So here again these are the two sets, and here we see that A is the image of 1 as well as the image of 2. So two elements of A is corresponding to single image in B. So this is called a many-one function. Onto function, a function becomes onto if the range is equal to the codomain. If range is equal to codomain, it becomes an onto function. It is also called a surjection. And if a function is one-to-one and onto, then it is called a bijection. So this sums on bijections we will do in the exercise. So here for example, A is equal to 1, 2, 3, B is equal to ABC. This is the function. Here the images are A, B and C, and that is the range is equal to the codomain. So it is an onto function. Into function, the range will not be equal to the codomain. So see here, A, B, C is the range, whereas the codomain is A, B, C, D, E. So this is an into function. Special cases of function, constant function. Here the image will be a single element only. So here the range of f contains only one element. Identity function, if A is a non-empty set, then the function f from A to A is defined by fx is equal to x for all x belonging to A. So here example, A is equal to 1, 2, 3. So identity function of A is the set. The first element, the image will be the same element. So here 1, 1, the image of 2 is also 2, image of 3 is also 3. So this kind of function is called an identity function. Real valued function, a function f from A to B is called a real valued function if the range of f is a subset of R. So representation of a function may be represented by a set of ordered pairs, a table form, an arrow diagram, or a graph. Vertical line test. A curve drawn in a graph represents a function if every vertical line intersects the curve at only one point. We'll do sums on this, it will become more clear. Horizontal line test. A function represented in a graph is one-to-one if every horizontal line intersects the curve at only one point. Okay. Let's go to the exercise. Question 1. Determine whether the graph given below represent functions. Give reason for your answer concerning each graph. So here this is the x-axis, this is the y-axis, and this is the curve. So let's find if this curve is a function or not. Draw a vertical line like this. It is cutting the curve in 2 points, so it is not a function. Here this is the curve. Draw any vertical line. It will cut the curve in only 1 point. So this is a function. So here is the curve in the shape of S. You would draw a vertical line. It is cutting the curve in 3 different points. So it is not a function. Here the curve is the straight line. You draw any vertical line. It will cut this line in one single point. So it is a function. Question 2. If let f be from A to B be a function defined by fx is equal to x upon 2 minus 1, where A is this, B is this, represent the f by set of ordered pairs. So let's first do the set of ordered pairs. So here is A, here is B, here is the function. So first you take the first element of A, put it in this function, and you will get the image. That is, here it is 0. Okay, so write down the first ordered pair. For the element x, that is 2 here, the image is 0. Similarly, take the next element 4, put it in this expression, and you will get the image as 1. Put 6, you will get the image as 2. You have to put all these values of x here. and you'll get all these images. Write it in this form, and this is called the ordered pair, set of ordered pairs. Okay, this is the tabular form. So here are the values of x. X belongs to the set A. So write down all the values of set A, 2, 4, 6, 10 and 12. Fx is what we are going to find. Okay, so put the value of x is equal to 2 here in this formula, and you will get the value of fx. So you can put it here. So these are also called the images. So this is the tabular way of representing this function. Okay, arrow diagram. So here you put down the values, x values, and these are the fx values, and you connect them through this arrow like this, and this will become the arrow diagram. Graph. So these are, the ordered pairs. You can plot those points on a graph paper. The first ordered pair was 2, 0. So this x-axis is the x value, and the y-axis is the fx value. So x value is 2, then fx is 0. When x value is 4, this is 1. So plot all these points and join them, you will get the graph of the function. Okay, question 3. Represent the following function through an arrow diagram, table form or a graph. So they have given you in the ordered pairs, set of ordered pairs. So you are going to draw the diagram. So first draw the arrow, the oval shapes, and write down all the x values, 1, 2, 3, 4, 5. Okay, and then corresponding to that write down the images in the next, and you can draw the arrows. So here you see that 3 elements, 1, 2 and 3 has the same image 2. So all these arrows will point towards the 2. Similarly, you can write it in tabular form. It can be in this vertical way also you can do, or horizontal also, doesn't matter. So first is x and then fx. Write down the values of x, 1, 2, 3, 4, 5. Write down the value of fx. They've given it 2, 2, 2 and then 3 and 4. So this is the tabular form to write the function. Now this is the graph. So you have all these ordered pairs. They are the coordinates. This is x and this is fx. So here you can plot these points and join them, all these points. Question 4. Show that the function f from n to n defined by fx is equal to 2x minus 1 is a one-to-one but not onto. So here it's n from n to n. So n is a set of natural numbers, and this is the function fx is equal to 2x minus 1. So put some values. Take x is equal to 1. You will get this image of 1. So image of 2 is 3. Image of 3 is 5. Image of 4 is 7. So what is the range? This is 1, 3, 5, 7, and this is the domain. And codomain is also n, because the function is from n to n. So distinct elements of domain has distinct images. You can see all images are different. So it is one-to-one. The codomain is not equal to the range, hence it is not onto. Question 5. Show that the function f from n to n defined by fm is equal to m squared plus m plus 3 is 1 to n. So here you should not get confused that why it is not x. Actually it can be any alphabet. So here they have taken m. So it's the same process. So f is equal to, f is from n to n is natural number set, and this is the function. Okay. So put the value of m is equal to 1. You will get the image of 1 as 5. Put m is equal to 2. You will get the image as 9. Put m is equal to 3 in this formula and you will get 15. Put m is equal to 4, you will get 23. So what is the domain? Here it is natural numbers. Codomain is also natural numbers. Range is this. So here distinct elements have this distinct images. So this is a one-to-one function. Question 6. Let a is equal to this, b is equal to n. Let f be from a to b be defined by fx is equal to x cubed. Then find the range of f. Identify the type of function. Again simple, the same method. Write down a, write down b. That is a set of natural numbers. So this is the function. Put the value of x as 1. Get its image. put 2, get the image, 3, get the image. So write down the domain, the codomain and the range. Here we can say that distinct elements have distinct images. So it is 1 to 1. And the codomain is not equal to the range. So it is an into function. Okay. Or you can say it is not onto. Better to say it is an into function, because they are saying identify the type of function. It's an into function. Question 7. In each of the following cases, state whether the function is bijective or not. Justify your answer. So bijective means that the function should be 1 to 1 as well as onto function. So okay, let's take the first one. That is the function 2x plus 1. So find out for distinct values, you will get distinct images. So hence it is a 1 to 1 function. And then these images, whatever you get, they are all part of this set R only. So actually the range is equal to the codomain. So it is an onto function, hence it is bijective. Question 7. Okay, the same thing, second question. Here the function is 3 minus 4x square. So we have to find out whether this is bijective or not, whether this is a 1 to 1 function. So here it is, function from R to R, defined by this function. Okay, now I am going to take two values, that is minus 1 and 1, and show that they both have the same image. So x is equal to minus 1 if I put here. So here it becomes 3 minus 4 minus 1 whole square. This will be minus 1, the answer. Similarly 5, 1 if I put, also I get the answer as minus 1. So two distinct images of the domain has got a single image in the codomain. So this is not a 1 to 1 function, hence it is not bijective. Question 8. Let a is equal to minus 1, 1, b is equal to 0, 2. The function f from a to b is defined by fx is equal to ax plus b is an onto function. Find a and b. Okay. So here is the set a, minus 1, 1, b is equal to 0, 2, and this is the function. Okay. So f of minus at minus 1. So put x is equal to minus 1, it becomes minus a plus b is equal to 0. This is the image, 0. So a is equal to b. So now take the next value, f1, put the value of x as 1 and it will give the image as 2. So a plus b is equal to 2. So substitute b as a. So a plus a is equal to 2. So 2a is equal to 2, a is equal to 1. Put the value of a is equal to 1, you will get b is equal to 1. That is the answer. Question 9. If the function f is defined by this, find the value of f3, f0, so forth. So yeah. So here is the function. So here the function depends upon the value of x. So let's see. The first value is 3. Okay. So 3 is greater than 1. So we have to take fx is equal to x plus 2. So I have taken for first one x plus 2. So f3 is, put the value of x as 3, 3 plus 2, 5 is the answer. Okay. Next one is 0, f0. 0 will come here. It is in between minus 1 and 1. So if x is equal to 0, then fx is equal to 2. So f0 is equal to 2. Okay. The next one is, third one is f of minus 1.5. 1.5 minus 1.5 is in this range. It is in between minus 3 and minus 1. So you have to take fx is equal to x minus 1. So fx is equal to x minus 1. So f of minus 1.5 is equal to, put the value of x as minus 1.5, minus 1 is equal to minus 2.5. Okay. The last one is f2 plus f of minus 2. First find f2. Where is 2 greater than 1? So you have to take x plus 2. So put the value of x as 2, you will get 2 plus 2, 4. And f of minus 2, it comes in this, x minus 1. So minus 2 minus 1 is equal to minus 3. So this f2 plus f minus 2 is equal to 4 minus 3, that is equal to 1. Question 10. the function f brackets minus 5 comma 9 to r is defined as follows. So again the similar type of sum, for different values of x you will get different functions. First let's write down. Okay, so if the value of x is in between minus 5 to 2, so for x is equal to minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, the value of fx will be 6x plus 1. Fx will be 5x square minus 1 if x is between 2 and 6. So if x is equal to 2, 3, 4, 5, this value of function. And fx is 3x minus 4 if x is equal to 6, 7 and 8. 3x minus 4. So this will make it more easy to understand. Okay, so we have written this down. Now let's do the first one. F minus 3 plus f2. So f minus 3. Let's find out what is f minus 3. So yes, minus 3 is here. So we have to use this function. So 6x plus 1. So 6 into minus 3 plus 1. That is minus 17. f2, it is here. So we have to use this formula. So 5x square minus 1. So 5 2 square minus 1 is 19. So this plus this is equal to minus 17 plus 19. That is equal to 2. Okay, the second sum is f7 minus f1. So where is 7? 3x minus 4. Okay, so 3 into 7 minus 4, that is equal to 17. But f1 is here. So 6x plus 1. So 6 into 1 plus 1 is 7. So f7 minus f1, 17 minus 7, that is equal to 10. Okay, the third sum is this 2 into f of 4 plus f of 8. So let's find f of 4 first. So where is 4? Here. So you have to use this formula. 5 into 4 square minus 1. And f of 8 is here. So 3 into 8 minus 4. So this plus this. So 2 into this, put it in the bracket. 5 of 4 square minus 1 plus 5 f8. 3 8 minus 1. So here you solved it. So 4 4s are 16. 16 5s are 80. 80 minus 1 is 79. Plus 3 8s are 24. 24 minus 4 is 20. Solve it, you will get 178. Okay, then the fourth sum. So here we have a numerator here 2f minus 2 minus f6. So first let's do the numerator. 2 into f minus 2. What is f minus 2? Minus 2 means you have to use this formula. 6 into minus 2 plus 1 minus f6. Where is 6? Here it is. 3x minus 4. So 3 into 6 minus 4. So solve this, you will get minus 36. Similarly, f4 plus f minus 2. f4, 4 is here, use this formula. Minus 2 is here, use this formula. Put the values of x, solve it, you will get this 68. Then you can solve the expression. Numerator upon denominator, if you put, you will get the answer. Question 11. The distance s an object travels under the influence of gravity in time t seconds is given by st is equal to 1/2 gt square plus at plus b, where g is the acceleration due to gravity. A and b are constants. Verify whether the function st is 1 1 or not. Very simple sum. So st is equal to this. So let's put the values of t, different values. 1 if you put, you will get this formula. This becomes this g upon 2 plus a plus b. If you put t is equal to 2, it becomes 2g plus 2a plus b. If you put t is equal to 3, it becomes 9g upon 2 plus 3a plus b. So distinct values of t will give us distinct values of the function. So this is a one-to-one function. Question 12. The function t, which maps the temperature in Celsius C into temperature in Fahrenheit F, is defined by Tc is equal to F, where F is equal to 9 upon 5C plus 32. Find T0, T28, so forth. Okay, let's, so this is the function. Tc is equal to 9 upon 5C plus 32. So first T0, that means when the Celsius degree is 0. So put the value of C is equal to 0 and you will get the Fahrenheit value. This is the answer. When the Celsius temperature is 28, you put the value of C here and you solve it, you will get the Fahrenheit temperature 82.5 degrees. Similarly, when the Celsius degree is -10, put the value here, get the Fahrenheit temperature. Okay. So number 4, they have given us the Fahrenheit temperature as 212. They are asking us to find the Celsius. Again simple, put it in the same formula and you will get the Celsius temperature. Here they are saying the Celsius temperature as well as the Fahrenheit temperature is same. Let us say that it is X. So put it in that formula. So you solve that formula, you will get the value of X as -40. So this temperature, the temperature when Celsius value is equal to Fahrenheit value is -40. So here we come to the end of the exercise. Please go through the video once again, pause the video in each sum and practice them.